Right now, as you are watching this, there's a river of wind moving nearly 6 miles above your head, and this summer it has barely CET is the reason more than 10,000 people have died from heat in Europe since late May. It is the reason nearly 200 million Americans were placed under heat alerts around the 4th of July, on the very weekend the country marked its 250th birthday. It is the reason Salt Lake City set an all-time temperature record, then broke it again 12 days later. It is the reason a heat dome that baked the eastern United States flipped, almost overnight, into a heat dome that baked the western United States instead, while Canada dealt with flash floods and power outages the very same week it was breaking heat records of its own. This is the story of the jet stream, the invisible highway, of wind that decides where heat gets trapped and for how long, and what scientists are now saying about why it keeps getting stuck in 2026 specifically. No hype, no recycled numbers, just what the data from the World Meteorological Organization, the World Health Organization, and the researchers actually studying this phenomenon says. If in Europe, in North America, or anywhere else, drop a comment and tell me where you are and how hot it has actually gotten where you live. I read every one of these. If you want grounded weather coverage instead of panic headlines, subscribe. It costs nothing. And a like helps this reach people who need to again next summer. Let us go for 5,000 likes on this one. Thank you. Now let us get into it. To understand anything that happened this summer, you first have to understand what the jet stream actually is, because almost everything downstream of it, including literally every heat wave we are about to walk through, traces back to this one mechanism. The jet stream is a narrow band of extremely fast-moving air, typically found somewhere between 30,000 and 34,000 feet above the surface, roughly the cruising altitude of a commercial airplane. It exists because of temperature difference. The Arctic is cold, the tropics are hot, and that contrast drives a river of wind that flows generally from west to east around the globe. When the temperature difference between the pole and the equator is large, the jet stream runs fast and relatively straight, and weather systems get pushed along quickly, rarely lingering anywhere for long. When that temperature difference shrinks, the jet stream slows down and starts to wander, developing large, lazy loops instead of a straight line. And when a loop gets big enough and holds still long enough, it can trap a dome of high pressure directly beneath it, locking hot air in place over one region for days, sometimes weeks, while a different region sits under an unusually cool trough on the other side of the same wave. That stuck, looping pattern is what meteorologists have been describing all summer as an omega block, named for the Greek letter it resembles on a weather map, because the high pressure ridge and the two lower pressure troughs flanking it form a shape that looks almost exactly like the letter omega. Omega blocks are not new. What to walk through in detail is how often this exact pattern has been showing up in 2026 and why. Europe's summer began going wrong in late May, more than 3 weeks before the solstice, when an early heat dome pushed temperatures well above normal across more than a dozen countries. Portugal reached 40 degrees Celsius, and southwestern Spain reached 39, numbers meteorologists said were startling for that point in the calendar, since Central Europe's weeks later. That first wave killed people even in late May, and it was only a preview. The second wave, and by far the more severe one, began on June the 17th, just days before the summer solstice, and it is the one that rewrote the record books across the continent. Météo France declared June the 23rd the country's hottest day since national records began in 1940. 7, with the town of Pissos reaching 44.3 degrees Celsius. Poitiers broke a record that had stood since 1947 as well, hitting 41.2 degrees. Spain's national weather agency confirmed that June the 22nd, and in mainland Spain since at least 1950, with the town of Anajar reaching 45.1 degrees Celsius, the highest temperature recorded anywhere in Europe during this entire event. The Czech Republic recorded 41.9 degrees at a station north of Prague, its highest reading ever registered. Germany hit 41.7 degrees near the Polish border, breaking a record that had been set only 24 hours earlier. The United Kingdom recorded 37.7 degrees, its hottest June day ever measured. And by early July, the UK had logged 8 separate days above 34 degrees Celsius in a single calendar year, more than it had ever recorded before. Switzerland hit 38 degrees, its hottest June temperature on record. Denmark hit 36.6 degrees, a provisional all-time national record. Poland recorded 40.5 degrees in the western town of Slubis, edging past a record that had stood for more than a century. And in the eastern German town of Kubschwitz, overnight temperatures never dropped below 29.4 degrees Celsius, the warmest night recorded there since records began almost 150 years ago, which matters because it is the nights that do not cool down that are often the most dangerous part of a heat wave for the human body. Belgium's experience during that second wave is worth sitting with on its own. because the numbers coming out of it are genuinely staggering. Temperatures in the city of Uccle reached 35.3 degrees Celsius. Between June the 18th and July the 1st, the country's public health institute, Scienzano, recorded 1,747 excess deaths, an excess mortality rate of 48%, above what would normally be expected for that period, making it the deadliest heatwave Belgium had experienced in at least 30 years. On June the 24th, as households across the country ran air conditioning units that most European homes were never actually built to need, wholesale electricity prices in Belgium spiked past €1 per kilowatt hour at sunset, as conventional power plants were pushed to their limits trying to keep up with demand. Public events were cancelled outright. The annual Battle of Waterloo historical reenactment was called off. In France, consumption over a summer weekend specifically to reduce pressure on emergency medical services, and the Eiffel Tower and the Louvre both began closing early because of the heat. French health officials reported at least 18 deaths in the country from that stretch alone, including 2 young children found unconscious in a family car in the town of Carpentras, and 3 elderly residents in the Bordeaux region who died from heat-related health complications over a single weekend. Authorities also reported 13 additional drowning deaths that same weekend, since heat waves reliably push more people toward unsupervised swimming to cool off, which is itself a recognized secondary danger of extreme heat events. By July the 10th, with a third separate heat wave now striking the United Kingdom, the continent-wide toll from this entire sequence of 2026 heat waves had climbed past 10,400 excess deaths, according to National Health Agency reporting compiled across the affected countries, with Germany absorbing roughly 5,120 of those deaths, France around 2,025, Belgium its 1,747, Spain 1,028, and the Netherlands close to 480. The World Health Organization's Director General, Tedros Adhanom Ghebreyesus, stated publicly that Europe is now the fastest warming continent on the planet, warming at roughly twice the global average rate, and said the continent's building stock, designed for generations to retain heat through cold winters rather than release it during hot summers, was simply not built for what it was now being asked to withstand. He called heat stress a silent killer and pressed European governments to adopt formal heat health action plans. Even as temperatures eased slightly through late June, the ground beneath Europe stayed dangerously dry, and that is where the third and most recent chapter of Europe's summer comes in. On July the 8th, Barcelona recorded 40.5 degrees Celsius, its highest maximum temperature since records there began. The following day, a wildfire broke out in Almeria province in southeastern Spain, killing at least 12 people and injuring at least 8 more, with 23 others reported missing in the immediate aftermath. Spain's Carlos III Health Institute had already reported at least 1,028 heat-related deaths during the June event alone. Researchers studying the broader pattern have described what is now happening across the continent in stark terms, noting that heat waves of this magnitude are now roughly 30 times more likely to occur than they were in the era before human-caused climate change, and that what would once have been considered a once-in-300-year weather event is now happening more often than once per decade. While Europe was absorbing its second and deadliest wave, an entirely separate but mechanically related heat dome was building over the United States. On June the 26th, meteorologists described a heat dome forming over the eastern half of the country as the most widespread heat wave the region had seen all summer to that point, driven by the same kind of jet stream shift now becoming familiar on both sides of the Atlantic. Cities including Chicago, Detroit, St. Louis, Dallas, and Nashville hit their highest temperatures of the year so far. By early July, as the country prepared to mark the 250th anniversary of its independence, the heat had only intensified. Roughly 150 million people, close to 1 in every 2 Americans, were placed under heat alerts, a number that climbed closer to 200 million by the peak of the holiday weekend itself. In Washington, D.C., the 4th of July was forecast to be the hottest Independence Day on record, reaching 101 degrees Fahrenheit, breaking a record of 100 degrees that had stood since 1919. The 3-day stretch surrounding it was on pace to be the hottest 3-day period in the capital since 1930. New York City hit triple-digit temperatures for the first time in a decade. Philadelphia forecast a high of 104 degrees, tying its all-time July monthly record. Boston set daily records for several consecutive days, with highs at or near 100 degrees each day. Heat indices, which combine temperature and humidity into a single measure of how the heat actually feels on the human body, climbed above 100 degrees and approached 110 degrees Fahrenheit across the eastern two-thirds of the country. The event coincided directly with both the nation's 250th anniversary celebrations and several matches of the ongoing FIFA World Cup. forcing organizers of major outdoor events, including a large national celebration on the National Mall in Washington, to add misting tents, cooling stations, and mobile medical support, specifically to manage the heat risk to attendees. North of the border, Canada was dealing with the same heat dome from the opposite side of it, and then with a violent transition out of it. Ontario and Quebec sat under heat, warnings as temperatures climbed toward 37 degrees Celsius in some areas heading into Canada Day. Then, between July the 4th and July the 6th, a series of severe thunderstorms tore through the United States and broke up the eastern heat dome entirely, a process that itself came with real consequences. Those storms caused more than 1.3 million power outages and at least 4 additional fatalities and are believed to have produced the largest hailstone ever recorded in the state of Connecticut. In Canada, storms on Canada Day itself brought widespread flooding and left thousands of homes without power, even as the broader region continued setting heat records through the following weeks, including a new all-time high recorded in Manitoba in mid-July. Here is where the jet stream mechanism becomes impossible to ignore, because almost immediately after breaking apart over the eastern United States, an entirely new heat dome began building over the western half of the country, and meteorologists explicitly tied its formation to the exact same jet stream displacement that had just finished baking the east. Beginning around July the 6th, Phoenix, Arizona reached 113 degrees Fahrenheit. On July the 12th, Salt Lake City, Utah recorded a new all-time high temperature of 109 degrees, and on that same day, Billings, Montana reached 111 degrees, a reading the National Weather Service described as an all-time heat record for the city, even though a reading of 112 degrees had technically been recorded there back in 1901, illustrating just how far back you sometimes have to go to find a comparable event. By the second week of July, forecasters were describing this western heat dome as likely to bring the highest temperatures of the entire season so far, potentially eclipsing even the extreme heat recorded earlier in the spring in Phoenix, Las Vegas, and Palm Springs, California. Denver was expected to see highs in the low to mid-90s for much of the following week, climbing toward 100 degrees by the following weekend, while Salt Lake City was expected to push into the low 100s. As this heat dome strengthened, it also shifted the jet stream itself out of the United States entirely and up into southern Canada, a direct, visible example of exactly the mechanism this entire video is built around. A temperature inversion beneath the heat dome trapped a considerable amount of wildfire smoke over the interior west, creating widespread poor air quality even in areas untouched by active fires, while an already drought-stricken landscape, including the area around an ongoing large wildfire in Utah, faced an elevated risk of new fire starts, even though the same high-pressure pattern driving the heat was, at least temporarily, suppressing the gusty winds that would otherwise have fanned those flames further. Taken together, the 2026 North American heatwave, as it is now being cataloged, has been tied to at least 44 confirmed deaths as of the most recent tallies, a toll compiled across both the initial eastern heat dome and the storms that eventually broke it apart. Compare that number to the more than 10,400 excess deaths recorded across Europe over a comparable stretch of the same summer, from heat waves that in some cases reached similar or even lower peak temperatures than what parts of North America experienced, and you arrive at the same kind of uncomfortable comparison that shows up again and again in disaster reporting. The heat itself was not radically different in intensity between the two continents. The outcome was the vast majority of American homes have some form of air conditioning, while only around 20% of European homes do, a legacy of a continent whose housing stock was built for generations to hold heat in through long, cold winters rather than release it during increasingly hot, increasingly frequent summers. That gap in adaptation, not a gap in how hot the air actually got, is a significant part of why the same broad weather pattern produced such different death tolls on opposite sides of the Atlantic. So why has the jet stream been getting stuck this way? And why are scientists treating 2026 as part of a pattern rather than a one-off unlucky summer? The leading scientific explanation traces back to research led by climate scientist Michael Mann, working with colleagues including Stefan Rahmstorf, Vladimir Petukov, and Kai Kornhuber, first published around 2017, and expanded upon in subsequent studies through 2018 and again as recently as 2024. Their research describes a phenomenon called quasi-resonant amplification, sometimes shortened to QRA, which is a genuinely useful concept once you strip away the technical language around it. Large-scale atmospheric waves, the loops the jet stream naturally forms as it moves around the planet, can under certain conditions become effectively trapped within a narrow channel of the atmosphere, amplifying in size and, crucially, becoming far more stationary than they would otherwise be. Instead of a wave moving steadily eastward and carrying weather systems along with it within a few days, a resonantly amplified wave can hold nearly still for a week, 2 weeks, sometimes longer, locking a heat dome over one region and a cooler, stormier trough over another for an extended stretch. Mann and his colleagues have shown a measurable increase in the frequency of these stuck, resonant jet stream patterns over the past several decades. And that increase correlates closely with a separate, well-documented phenomenon called Arctic amplification. The fact that the Arctic is warming considerably faster than the planet, as a whole, by some estimates, close to 4 times the global average rate. Arctic amplification matters here specifically because the jet stream's strength and straightness depends directly on the temperature difference between the pole and the equator. As the Arctic warms faster than the tropics do, the temperature gradient shrinks, and a shrinking gradient is precisely the condition that favors a slower, wavier, more resonance-prone jet stream, the exact kind of pattern behind essentially every heat dome described in this video. Mann's team has also found that these resonance conditions become more frequent in the years following strong El Nino events, which brings in the final major piece of this year's puzzle. On June the 11th of this year, NOAA officially declared that an El Nino event was underway in the equatorial Pacific, and flagged, in that same announcement, the strongest El Nino events ever recorded, with some forecast models suggesting a potential peak later this year, capable of rivaling the historic 1997 to 98 Super El Nino, among the most extreme such events in the modern instrumental record. Climate scientists have been careful to note that the relationship between El Nino and any single heat wave is not a simple, direct one, and that this year's event is unusual in several respects, arriving unusually early and unfolding inside a global climate that is already fundamentally warmer than it was during past El Nino cycles, which limits how cleanly past El Nino summers can be used to predict this one. Even so, record warm sea surface temperatures building in the central Pacific are already shifting where and how tropical storms form and release their energy, and that shift is itself capable of further distorting the jet stream over North America. Specifically, which is part of why several meteorologists tracking this year's pattern have pointed to the still developing El Nino as a contributing, amplifying factor behind the heat dome that flipped from one side of the United States to the other within the span of about 2 weeks. None of this is speculation dressed up as science. The World Weather Attribution Group, an international collaboration of climate researchers who specialize specifically in rapid analysis of individual weather events, has already released findings on both the European and North American episodes of this summer's heat, concluding in each case that the specific combination of extreme heat and, in some instances, extreme humidity recorded would have been, in their words, virtually impossible without the influence of human-caused greenhouse gas emissions. The World Meteorological Organization separately confirmed that Western Europe had just experienced its hottest June on record, with average temperatures running roughly 2 degrees Celsius above the 1991 to 2020 average for the month, a margin that sounds small, stated as an average, but that translated, in practice, into more than a dozen individual national temperature records, falling within a span of about 6 weeks. So what does all of this actually mean for you, watching this wherever you happen to be? It does not mean every summer from here forward will look exactly like this one. The particular alignment of this year's El Nino and plain year-to-year variability still play a role in whether a given summer produces a resonant, stuck jet stream pattern or a faster, more typical one that keeps weather systems moving along normally. What the data does show consistently across multiple independent research groups is that the underlying conditions capable of producing these stuck patterns, a warming Arctic, a shrinking pole to equator temperature gradient, and an increasingly warm baseline ocean for El Nino events to build on top of, are becoming measurably more common, not less, as the decades pass. The practical takeaway echoes something worth remembering from disaster coverage generally. It is not the raw intensity of a weather event alone that determines how many people it hurts. It is how much warning people receive, how their homes and cities were built to handle it, and how seriously an early heat warning gets taken before the heat itself actually peaks. Checking on elderly neighbors and relatives before a heat dome arrives, rather than after, tends to matter more than almost anything else in these events, since the overwhelming majority of heat deaths recorded across both continents this summer involve people over the age of 65 or people without reliable access to cooling. The honest, grounded summary of this entire summer is this: a slower, wavier jet stream, increasingly linked by researchers to a rapidly warming Arctic, has repeatedly stalled into stationary omega block patterns across the northern hemisphere throughout 2026, trapping heat domes in place for days at a time instead of allowing weather systems to move through normally. That pattern drove 3 separate heat waves across Europe between late May and mid-July, killing more than 10,400 people, according to national health data compiled across the continent, shattering national temperature records in at least 13 countries along the way. The same underlying mechanism built a heat dome over the eastern United States around the 4th of July, placing close to 200 million Americans under heat alerts during the country's 250th anniversary celebrations, before a series of severe storms broke that dome apart and an almost identical heat dome immediately reformed over the western United States. Instead, setting new all-time records in Salt Lake City and Billings within days of each other. A developing El Nino event, possibly on track to become one of the strongest ever recorded, sits underneath much of this as an amplifying factor, while a shrinking temperature gradient between the Arctic and the tropics, driven by Arctic amplification, appears to be making the jet stream itself increasingly prone to getting stuck in the exact resonant pattern that produces events like this one in the first place. We are going to keep tracking this jet stream pattern as the rest of summer unfolds, sourced the same way we did today, straight from the World Meteorological Organization, the World Weather Attribution Group, and the researchers actually publishing on quasi-resonant amplification, not recycled headlines dressed up as breaking news. Subscribe so you do not miss it when this pattern shifts again, because based on everything we just walked through, it likely will not take long. And leave that comment below. Tell me where you are watching from and how hot it has actually gotten near you this summer. Because behind every one of these numbers is a family in Belgium running an air conditioner their house was never designed to need, a father in Carpentras who will never get an ordinary afternoon back, and a firefighter in Almeria who spent this week walking through the exact kind of dry, wind-starved landscape that a stalled heat dome leaves behind. 5,000 likes on this one. Let us go. See you in the next one.